hope anyway, is the use of the various different distribution forms. So we'll start by looking on our simulation page here at the capital cost of plant. Now, history tells us that construction projects almost always overrun on cost, very rarely come under cost. So we probably want a distribution that's going to be low quantities at the low end of cost, and high quantities of simulations at the high end of cost. So here we're going to use the beta distribution model, and we're using 2, 0.5 for the alpha and the beta. Then we have our minimum and maximum values. And then that then is used with the random function to calculate this particular field. Now, what I want to show you is that if I take these 1,000 simulations and we see what the distribution looks like. So we'll come down here, okay, like that, and then we're going to come back up to the top now. And we're going to say insert, and we're going to pick this particular graph right here. Okay, and you can see that the distribution starts out small numbers at the low end and higher numbers at the high end. So we're more likely to be expensive on the overruns on the building and not underruns. Okay, so that would be that piece. Now, the total waste in tons used a different approach. Here we use 2, for our alpha and beta, otherwise the same. Now let's just see what that looks like. 2, 2. Now we see a normal distribution. Okay. For our annual cost of plant, we have a 0.5, 2. And now we can see that that particular distribution model is high at the low end and low at the high end. So the opposite of what we used for the capital cost function. And then finally here, the economic cost of disposal per ton. We used a 0.5, 0.5, and what that looks like is high on one end, high on the other end, small in the middle. Now, I wanted to show you what the normal distribution function looks like. Now here, we have to use something a little different. So it's normed on I and B. We then enclose inside that the rand function to get a random value. But we need the mean and the standard deviation. And you haven't generated those yet. So let's go back to our assumptions page. By the way, if we switch this over to that, we get a standard distribution. Okay, so let's go back to our assumptions page. And you can see that I added 2 new columns on our assumptions page, the mean value and the standard deviation. Now the mean value is very simple. You just take the average of the minimum and the maximum, and that gives you your mean. But the standard deviation is a little more tricky, because in order to calculate the standard deviation, you need at least 30 observations. So what I did was, down here, is I created 30 observations for each of those values by using the random function. Okay, for each one of these. So I got random numbers between the two. And then I took the standard deviation of that range, and that gives me the right standard, or very close to the correct standard deviation for those values. Okay? Which I can then use in my simulations to get my normal distribution. And so that is pretty much all the different forms that you can use based on what I've given you. There are more, but this represents pretty much everything you can use. And of course, if you just want something that's just flat, you would use something like this one here. So, and you can see it's basically flat, equally likely to fit any particular one versus that. Okay, so this is, should be enough to carry you forward.